Okay, now is Tin's turn.
Hello, Madrid. My name is Tin. I am an engineer at kiwi.com, and today we're going to talk about schema. We're going to talk about scheming. You might have heard this word before. We're not going to do it in the bad way, where you're planning to do something evil. We're going to do it in the good way, like engineers. So let's get to the introduction. We're going to talk about schema, about planning to do things, about preparing yourself for some big demanding projects, for some big things. How many of you work here in a big team, over 20 people? How many of you? Come on, raise your hands, don't be shy. Maybe like half of the, great. It's useful even for those who don't. If you collaborate at all, you could use planning. Even if you don't, if you work only with yourself, you will forget what you work at in a day, in two, in a week. It's good to have it planned down short. But first, let's make some introductions. My name is Tin, as I mentioned, and I work as a team lead in kiwi.com. I'm a lead of several engineers who work on mainly tackling demanding tasks on backend. Standa, that you've been listening to, works in automation. That's only one of the departments we connect together. We try to keep all these services working together, working well, and cooperating nicely. So one of them going wild doesn't break the other five. We basically act like some kind of policeman out there. But hey, it works. And it works in our company because we all have the same mission. We all push to make travel better. We all understand what to do. And we do it via technology. We do it via code. We're not just a travel agency. We're trying to make travel better by using code, by using technology to cut out the boring tasks. I'm going to get to code itself in a bit, but let me describe what the presentation itself is going to look like. I'm going to talk about schema, about how that schema works. How do we use it to use code to check what we're saying? We're also going to discuss how talking is not as beneficial as actual coding. Nobody likes to talk about a project they're going to do. Everybody likes to see it written down and know, these are the tasks I need to do. I don't need to guess. I don't need to figure it out myself. My boss wants me to do this, that, and there. And that's great. It's great to have defined, nice tasks. And that makes a healthy process. That makes everybody understand what they're supposed to be doing. So yeah, after we discuss some of these principles, I'm also going to show some examples. The whole presentation will be a little bit of me talking around the principles, explaining what I'm showing, and a little bit of showing the actual code. All the code is hosted on GitHub. You will be able to access it, no worries. All of it actually works. It can be run. You can try out, play with it. And I hope you do. I hope many of you try it out and find out that it's a great idea and start using it. So the examples, Python, I'm using Flask, I'm using Connexion as a framework. Did any of you hear of OpenAPI, aka Swagger? Anyone? Great, 2 or 3 people. That's perfect. Many of you will learn something new today. So, the examples will be an API that works and talks about birds. I don't know if any of you are bird watchers or have a bird at home. I personally don't know anything about birds, but I find them a cool topic. I find them a cool abstraction to talk about. So yeah, we're going to talk about birds in our API, and we're going to do it in a practical way. So you can use the examples for anything. It doesn't actually have to be birds. I just used it as a fancy example because nobody wants to hear about object number 37. It's much cooler talking about canaries. So yeah, let's go over some basics. What's an API? Application Programming Interface. Basically, it's a language your part of code uses to talk to my part of code. We have to communicate somehow. We have to have some parameters, some things to communicate. Anybody who does anything at web knows what an API is. Anybody who makes frameworks knows what an API is. APIs are everywhere. And they're very important if you're collaborating. If you're collaborating, you want to make your API be the best thing somebody can use, so they don't have to have a headache, so they don't yell at you. Next is schema. Schema goes, surprisingly, from the Greek word schema, which means plan. Oh, wait. Ah, there. Word plan. Basically, it's planning something and drawing it down. All engineers plan, usually. You have engineers, electrical engineers, who will plan your installations at home. You have architects and construction engineers who will draw down hundreds and hundreds of schemata. They will draw these huge plans, usually using AutoCAD, and they will scheme down everything before they even start calculating things. They will do all that before things start getting done. Programmers shouldn't be different. We should be forced to write down what we're going to do before we do it. So we just don't go wild and start coding and then figure out everything is broken after 10 minutes. But yeah, I push planning with schema because it's great for us. It's great to plan your things, to know what you're going to do, to know how you're going to do it before you actually do it. And that allows you to talk with other teams. Much, much easier. You probably have some colleagues who start coding before they even start thinking. They start writing code, they don't care, and then after implementation comes, they figure out, oh, I figured it out wrong, I need to go back to the drawing board, see you in 5 days. And they do it often. That's what happens when you don't think about the problem. You just think about how to solve it, how to go to the solution fastest, how to do as much as possible. Sometimes it's good to take a step back and start planning things. And for that, we use OpenAPI. It's a great thing. It's a tool that allows you to write down web APIs in a common language. That language doesn't have anything to do with your specific programming language. Examples today are in Python. It's great to use in Python, but it doesn't have to be. It doesn't have to be Python, and it doesn't have to be any specific tool. That's why it's great. Your colleagues in JavaScript, they're going to use it. Your colleagues who use PHP, sure. C, well, not C, but C++ or C#, sure. Most languages have some kind of a library and some kind of support for this. If there isn't some, it's not that hard to code, especially with all the validators around. So let's get to the example. Let's get to see what this OpenAPI schema is. Don't worry if you don't understand these fancy things like parameters, paths. We're going to go over them right away. So yeah, this is an example of our bird app, of our schema. There's some base path, there are some definitions. It says what it consumes, JSON, like most of the internet. It defines a bird, says some name, nest, wingspan. Those are properties of one bird in our API. We'll get back to this later, but it's important because it defines what a bird is. Like a class in a program, it is a stereotype of a bird. And then we'll get to define actual objects. Why is this useful? Because 5 of your applications should use the same concept of a bird. All 5 of them should have a name, nest, and a wingspan. They should all have a common understanding, a common language. That's a problem that needs solving in most of the systems today. You have this problem getting a common language around, and it's troublesome. And having a schema shared between applications is great to solve this. There's some more metadata, there's some info, a contact, who to contact when this goes haywire. It's great because you're responsible for your work. You're going to get angry emails if things go wrong. There is also what it produces, schema. The schemes here, it says HTTP. Don't use HTTP, use HTTPS. This is just a play example, so I didn't pay attention to it. Some tags are defined, so you can differentiate between multiple endpoints. We use this in production. We have dozens of tags, and they're great because you can toggle them and you can find exactly what you need to find. Then there's an example of a path. A path is actually what we use with APIs. How many of you have ever used web APIs? How many of you have made a handmade request? Come on, there has to be a bunch. Again, approximately half of you, great. So yeah, we define paths to access our application. And those paths have some functions they call in code, operation ID here. Functions are not a part of the API. They are part of the implementation, and that's great. Schema doesn't have functions in itself. It just calls this endpoint, this function in your code and then lays its hands off. How you implement it is up to you. How you do your business logic is your problem. But how you communicate to it is everybody's problem, and that's great. Because those people tomorrow who collaborate with you don't need to know how you're solving a problem. They just need to know how to tell you, hey, I need this solved. We'll get to the example further, but for now, you need to know that there's no functionality in Schema itself. It's just a blueprint to get your functionality across. So yeah, what else is great about OpenAPI? It's great because of its tooling, because of the support it has. Generally, you have a whole plethora of tools to choose from. You have a lot of things to play with, from the UI that's automatically generated, from the frameworks that create your whole API client just from your schema, to a lot of community out there which will tell you if you have a bad idea. You have some choices. Right now, we're going to choose to use Conexion for Python as a client, and you can choose to write your schema in YAML or JSON. The example a bit ago was in JSON. We actually wrote it in YAML because YAML is great and approachable for people. It's approachable for people who don't code. Personally, I'm a fan of JSON, but when my colleague who doesn't know how to do parentheses, curly brackets and stuff asks, it's easier to just send him YAML and tell, hey, serve yourself. A lot of us would like to have our colleagues self-service. So yeah, we use YAML because it's approachable. We have some non-tech people who want to see it, so it's a choice you can make otherwise if you want. Conexion, I mentioned it. It's a framework. It's built on top of Flask. Flask is going to be mentioned in a sec. It's a great framework that creates an HTTP client over your schema. It handles validation, etc. for you. So you don't have to worry about that minutiae of having these length strings, of having your schema this, that. It actually makes doing schema in Python wonderful. And an important reason of it is that it also validates your responses. So if you say that your application is going to return these 4 keys, if it's going to return a nest, a name, and a wingspan, if you don't return them, it will error on you in your test. It will not error in production. And that's invaluable. When you don't have colleagues calling you at midnight to say, hey, you broke my app, that's perfect. Flask. Flask is just a very fast micro framework for Python. It does just the basics. If you need something else, you need a database, import it. You need handling of specific content type, import it. It doesn't do anything presumably. It lets you implement stuff. It lets you grab your own things, bring your own stuff, make your own framework. It just does the basics. And Conexion builds on it. It just does the basics of handling your schema. This allows you to choose any kind of database engine. It lets you use any kind of add-ons and plugins for Flask, so you are very flexible. It allows you to, if you choose so, add this system to your own application in less than a month. It doesn't require a lot of coding. If it's a small application, you can do it in a day. So yeah, they're great. And together, they make the meat of our stuff. They let us build this system based on schema, based on the practical validation of what we're getting and what we're sending out. Our application for our teammates becomes a truly black box. They know what we return, they know what we accept, and the rest is up on us. So yeah, why the schema? Why the hype about schema? Why is it so great? It's great because we'll be enforcing it. We'll be forcing it to work. And we will have an automatic UI will have an automatic interface that shows everybody, hey, use my API this way, use my application in this certain way. And this will automatically generate from what we use for our code. So we will not have to update it ever. And if you've never had problems with outdated schema, you've never programmed. If you've never had bad documentation stop you, you're the luckiest people I know. So yeah, your documentation will not grow outdated. It will stay up to date. If it doesn't, you will get errors. You will fix it. And that's great. So yeah, more examples. This is the file structure of what we're going to use as the example. As I've mentioned, you don't have to worry too much. This is going to be on GitHub. This is going to be available, so you can check it later at your leisure. What's the basics to understand are how we have this schema directory. It has these YAMLs in it. There's some app. There are some handlers. They do things. Basically, we just boilerplate this stuff so we can later use it to run our application. This is the handler we have. Notice how the functions are all two-liners. The bird list in capitals is just a replacement for a database because I didn't want to bother. And it's a list of some birds. And I picked them off Wikipedia, so blame Wikipedia if the information is wrong. So yeah, notice how there's no boring formatting checks. There's not a check if the name is defined. There's no typing involved. There's nothing that checks, hey, is the input correct? Because the input is checked by Connexion automatically. If we write in schema that the bird name has to be defined and it has to have a certain number of characters, it will be so, or Connexion will return 400s. It will return validation errors. And your client will know, oh, bird name is not supposed to be none. And then they will fix it and you will work with them happily. So yeah. What's the reasoning of connecting schema between clients? You want them to have the same concept, to have a certain code, a certain schema, which you write together. So you meet, you say, okay, we're going to make an application that works with birds. What do we need? We need a name, we need a wingspan, we need some birds, we need something common to talk about. Then you will put this into a common repo which will not be touched by any of the teams directly. You will say, okay, we agree to work with these objects, and these objects are going to be our bread and butter. They are going to be what we do perform operations on. So you don't have the misunderstandings of one team understanding that, hey, wingspan is a number. The other person will say the wingspan can be a string that says centimeters, and the fourth team will send you a byte string and you will be super confused. No, you will agree, you will set the schema down, and it will validate on each of the places what you're passing and receiving. Thus, the communication will be very, very open, very, very direct. So yeah, that's the reasoning. We combine it by using formatting guidelines. Here, there is a little bit of a problem because Connexion is not doing this perfectly. You have problems where you have to connect your schema by yourself. There are tools that do it as a pre-formatting step. I'm not sure. In the next slide, we'll mention specky, which is a great tool to check your schema for errors, to check it all, clean it all up, and connect it. There are multiple of these tools. You can explore them at your own leisure. But basically, we will create combined schema for all our projects. If bird keepers want to post birds, want to create new birds that you are keeping, and bird watchers just want to have a list of existing birds, they should use the same object and they should share it. So you, as a user, can take one bird from the bird keepers, from the bird watchers, copy it, and see, okay, this is a cool bird, and then send it to the bird keepers as a request, I want to keep this bird. And that should work without you having to worry about formatting, about having to worry of anything really. That's shared with this little example of a bird. As I mentioned, name, wingspan, nest. Nest is a reference to other definition. Here's a nest. And there's also a tag that says birds, and there are avian endpoints. These are just simple examples of data structures. Enumerated types, like type and terrain, will be checked automatically. So if somebody wants to send you a bird that lives in a cage, you tell him no, birds naturally don't live in cages. You just check it all here. And it's consistent. If you share this by building your own schema, you share it between all your applications, and they all use the same object. I will take a quick digression to mention that we do this in production for a bag. We do travel. You've all probably traveled, and you've all probably brought a bag with you. And those bags can get complicated. Some airlines use kilograms. Some airlines use pounds. Some airlines have dimensions. Others make you have a sum. And it's a problem when one team implements it very simply and naively. You have 3 dimensions, have fun. And the other team overdoes it and has 17 different dimensions. Well, what we did was we used the schema to force them all to have the same bag, the same structure, and then use it between themselves. The same way here, we have a nest, and every nest has a type and terrain, and it has a set of values. The principle is the same. You create some schema, you create some idea, and you make all your clients, all your servers share it. So yeah, this sharing is getting improved every day. Connexion will have it naturally soon enough. I think some merge requests are already under review. Until then, use specky, share code. There are other means, but they can all be done programmatically, and that's what it matters. It matters because we want this to be done via code. We don't want to be forced to do it manually. Because if you do it manually, somebody's going to forget, somebody is not going to do it properly, and things will fail. So yeah, our product will be services working under the same schema. One of them to register birds, the other to keep birds and have them available to take for yourself. We'll be connecting them with this set of tools, and we will examine how will it work together. So yeah, here we can see the UI. This UI is completely automatically generated. You don't have to write a single line of code to get beautiful UI. If I had a laptop here, I would show you with clicking how it expands and shows around some cool features. But yeah, we have 2 different applications, and notice that they both have the same tag. The tag is defined only once in a centralized area, so you don't have to rewrite it. So you don't have to have a single team say, oh, this is bird without the S. The other says, this is birds. And yeah, they don't work together because they named it differently. Then we have an example of the get that shows you a specific bird. It returns it in this example value. All the examples you've defined in schema are automatically generated as example structures. So you just say that an example terrain is swamp, and then all your examples will have the swamp. You don't have to repeat yourself many times. And let's say you're naive and you just copy this because you like copying things, and you send it to the post endpoint on the completely different application. And you can know that it will work because they are sharing the same authentication code that was automatically generated. They're using the same formatting to get this working. So you don't have to worry if somebody understood the project documentation differently. And that's a great thing to have. That's a great problem to solve, especially the more projects work together. So yeah, some quick conclusions. Use schema, use documents that are generating code, because then you don't have to work with people, you don't have to talk, you don't have to make sure that people understand each other. If it's written down, it works and it validates itself, and that's invaluable. Reuse it, reuse schema for terminology. Don't make somebody explain what a bird is. Make him write it down. It's great because then that written down definition, which is humanly readable, will be used in your code and you will not have headaches. And a tight interface, an interface that is set in stone with the documentation, pays for itself. It really does. You may spend a day to figure it out. You'll save months debugging it in the future multiple times over. It's a great thing to do. So yeah, how to start? Use these tools. Try to play with them. Try to expand them. Try to make them a part of your product. If you have multiple services at your work, try to get some of them to use Schema. Try to get some of them to play with these tools. They don't have to be OpenAPI. There's also JSON Schema. There's multiple things out there. Play out. Check it out. There's plenty of them that you can experiment with, that you can use in your own environment if you don't use Python professionally. It's great. A lot of it is process. That process needs to be there. You need to realize with your colleagues that talking things a million times over is not going to fix things. Then you can separate that schema, version it, make sure that nobody makes changes lightly, and you will be in heaven pretty much. If you have some existing code that doesn't have any of this cool stuff, there's this cool article that you can check out, and it speaks exactly about that problem. It speaks about if you have an existing application that you cannot throw away, how to reverse engineer it with some cool tooling. And finally, here are some resources, as well as the repo I promised, some keywords that you can search around, find, play with, to get these things for yourself. And there are some useful links for API design, for having these tools to play with and to use them properly. This is the best part to take a picture of if you want. I know a lot of you take pictures of presentations, so I prepared a slide just for that. And we can get to questions. Thank you for your attention. Thank you for being a wonderful audience. And ask me something.
Questions?
Any hands? Tough.
Don't be shy.
You're wonderful. There it is. There's a second microphone.
I think that you should have put units in the wingspan.
In the description?
Yeah.
Very probably.
Yeah, because
we actually
in
put
different
units.
countries, in one they are going to use centimeters, and in the other are going to use inches, for example.
And that's why I shouldn't make this presentation on my own and have other colleagues comment on these things. Anyone else?
No?
Great.
Okay.
Thank you once more.
Tim.
Wonderful.